Welcome to the next session of subject engineering maths. We were in chapter 3, that is discussing vector calculus of calculus. In the last session, we have discussed the basic concepts, that is what is a vector, what is a scalar, dot product of vectors, cross product of vectors, divergence. Okay. Now let us start the session with the curl of a vector. So next definition is curl. Generally, the dictionary meaning of curl is rotation. The dictionary meaning of curl is rotation. Suppose we have a vector a bar equal to a1 I bar plus a2 z bar plus a3 k bar. Now, the curl of this vector is denoted by this curl a bar. This is nothing but del bar cross a bar. Del bar cross a bar. If a cross product is replaced by dot product, it is called divergence. Now, if dot product is replaced by cross product, it is called curl of a vector. Now, how to define this? Actually, when you discuss cross product between two vectors, it is a determinant. So, the first row is the components of unit vectors, that is I bar, j bar, k bar. Second row is the components of del vector. The components of del vector are partial derivatives. Dou by dou x, dou by dou y, dou by dou z. And the last row is the components of the last vector. They are nothing but a1, a2, a3. So therefore, this is nothing but curl of a vector. This is my vector a bar equal to a1i plus a2j plus a3k bar. Now curl a bar is nothing but del bar cross a bar. So since it is a cross product, it is nothing but a 3 by 3 matrix determinant value. So the first row is unit vectors I bar, j bar, k bar. Unit vector along x-axis, along y-axis and along z-axis. The second row is components of del vector dou by dou x, dou by dou y, dou by dou z. And the third row is the components of vector a1, a2, a3. Okay. Let us take an example. Suppose we have a vector r bar equal to xi bar plus yj bar plus zk bar. Now let us calculate curl of this vector. Curl r bar equal to del bar cross r bar. Basically, this is a standard position vector. Now this is the determinant of I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z. Components are x, y, z. X, y, z. Now let us expand this I bar into dou z by dou y minus dou y dou z minus j bar into dou z by dou x minus dou x by dou z plus k bar times data of this block. Therefore, this is dou y by dou x minus dou x by dou y. Now, dou z by dou y is 0, dou y by dou z is 0. Like this, all the partial derivatives are 0. So, this is a null vector. So, I write it as 0 bar. Therefore, curl of a standard position vector is a null vector. It is a 0. Since curl is a cross product of two vectors is a vector. So, I represent it as 0 bar, null vector. Okay. This is a null vector. Write the definition. Curl. Let a bar equal to a1 I bar plus a2 z bar plus a3 k bar. A bar equal to a1 I bar plus a2 z bar plus a3 k bar. Be any vector. Be any vector. So the curl of a bar is denoted and defined as curl of a bar equal to del bar cross a bar. Curl a bar equal to del bar cross a bar. So write this determinant followed by this example. Next definition is solenoidal vector, or this can also be called as divergence free vector. Divergence free vector. Now, when you look at this, we were saying that divergence free vector. Free divergence means it has no deviations along x-axis, along y-axis, and along z-axis. Or combinedly, you may have deviations, but when you combine all the deviations, there can be no deviation. Okay, let us see. Suppose I have a vector a bar. We say that this is a solenoidal vector if the divergence of this vector is 0. So a vector whose divergence is null is called a solenoidal vector or a divergence vector. Let us take one simple example. Suppose a bar equal to, for example, yi bar plus xj bar plus zk. For example, this is yi xk, or I will use like this. This is z. For example, this is x. Now let us take this vector yi bar plus zj bar plus xk bar. Now when you find the divergence of this vector, so div a bar equal to dou by dou x of y plus dou by dou y of z plus dou by dou z of x. Now all these partial derivatives will give 0. Therefore the entire result is 0. Therefore this is a vector whose divergence is 0. So this is an example of a solenoidal vector. So how to define this? A vector whose divergence is 0 is called a solenoidal vector or divergence free vector. Note this point. A vector whose divergence is 0. A vector whose divergence is 0 is called a solenoidal vector. A vector whose divergence is 0 is called a solenoidal vector. Note down this example. Next definition, irrotational vector, or this is also called as conservative vector. Conservative vector. See, actually irrotation means there is no rotation. Suppose if a vector is moving in any direction, whether vector is moving in the clockwise direction or anti-clockwise direction, whatever it is, then you will get some curl. Curl is some non-zero vector quantity. Generally, if a vector moves in any direction, generally, if a vector is moving in any direction, then it has some non-zero curl expression. But if a vector is not moving in any direction, such vectors are called irrotational vectors. In simple words, a vector a bar is said to be irrotational vector if curl a bar equal to null vector. So a vector whose curl is null vector is called an irrotational vector. When you take example, earlier we have seen standard position vector r bar equal to xi bar plus yj bar plus zk bar. Now this is an example of irrotational vector because its curl is null vector. Another example is I can take constant vector. For example, 2i bar minus 3j bar plus 4k bar. Here I am saying that the vector is constant. That means there are no changes in any one of these properties. That means this constant vector doesn't move in any direction. So even the components are constant. So 2, minus 3, 4. So basically what is called combination of partial derivatives along with unit vectors I bar, j bar and k bar. So dou by dou x, dou by dou y, dou by dou z of all these constants is 0. Therefore this is called a constant vector. This is called a constant vector. And when you look at the divergence it is 0, even its called is null vector. So this is an example of an irrotational vector and even solenoidal vector also. Okay, so write this point. A vector A bar is said to be irrotational. A vector A bar is said to be irrotational if called A bar equal to 0 bar. A vector A bar is said to be irrotational if called A bar equal to 0 bar. Examples. Write these two examples. Next we discuss the definition gradient. Suppose we have a scalar f in 3 variables x, y, z. Now this is a scalar expression, scalar quantity. Now the gradient of this vector, this scalar is denoted by grad f. So gradients can be evaluated only for scalars. It is a scalar in 3 variables x, y, z. Now its gradient is denoted by grad f. This is given by del f. This is given by del f. Now basically this is a vector. Del bar you can write, I write it as simply del. So this is a vector, but this is a scalar. So we don't have any operation between these two. If you write dot, it is illegal. Even if you write cross, it is illegal. So we don't have any operation between these two. This is simply del f. That means we are applying del vector to the scalar f. Now let us simplify this. Actually the del vector is dou by dou x I bar plus dou by dou y z bar plus dou by dou z k bar. Apply this vector to the scalar f. So this is given by dou f by dou x I bar plus dou f by dou y z bar plus dou f by dou z k bar. Therefore, when you find a gradient of a scalar, the result is a vector. What this point? The gradient of scalar is always a vector. Let us take an example. Suppose I have a vector a bar equal to, for example, f equal to the scalar, for example, x square plus y square plus z cube. Suppose this is my scalar expression. Now let us find its gradient. So del f equal to dou f by dou x I bar plus dou f by dou y z bar plus dou f by dou z k bar. Now here dou f by dou x is 2x. So this is 2x I bar. Dou f by dou y 2y z bar. Dou f by dou z is 3z square. So therefore its gradient is given by this vector 2x I bar plus 2y z bar plus 3z square k bar. Note this point. Let f of x comma y comma z, let f of x comma y comma z be any scalar in x, y and z. Let f of x comma y comma z be any scalar in x, y and z. Let f of x comma y comma z be any scalar in x, y and z. So the gradient of f is denoted and defined as grad f equal to del f. The gradient of f is denoted and defined as grad f equal to del f. So continue these two lines followed by this example. Note, the gradient of a scalar is a vector. The gradient of scalar is a vector. Next definition, length or norm of a vector. Length or norm. Suppose we have a vector a bar equal to a1 I bar plus a2 a bar plus a3 k bar. Now basically this vector is equivalent to a 3D point. This is a1, a2, a3. Now let us find length of this vector. Its length is denoted by this symbol. So write two vertical lines on the left side as well as right side. So this is length or norm of A. So this is the symbol for length or norm of A, which is given by the expression square root of a1 square plus a2 square plus a3 square. Now this you can treat it as like this. This is nothing but square root of a1 minus 0 whole square plus a2 minus 0 whole square plus a3 minus 0 whole square. Now this is nothing but distance of a1, a2, a3 from origin. Distance of a1, a2, a3 from origin. We know the distance between, we know the formula for distance between two two-dimension points or two three-dimension points. So square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square, like this. Therefore, whenever you take a vector like this, it is equivalent to a 3D point a1, a2, a3. Now this is the symbol we use to write to represent length or norm of a vector A. So this is length of or norm of vector A bar, which is given by square root of a1 square plus a2 square plus a3 square. So this is nothing but distance of a1, a2, a3 from origin. Suppose when you take example, suppose a bar equal to 2i bar plus j bar minus 2k bar. Now when you look at this, its length, so norm a bar equal to square root of 2 square plus 1 square minus 2 whole square. So this is square root of 4 plus 1 plus 1. 4 plus 1 plus 4. So square root of 9, and this is given by 3. So its length is 3. Write this definition. Let a bar equal to a1 I bar plus a2 z bar plus a3 k bar be any vector. Let a bar equal to a1 I bar plus a2 z bar plus a3 k bar be any vector. The length or norm of a bar. The length or norm of a bar is denoted and defined as this is equal to square root of a1 square plus a2 square plus a3 square. So next you continue these two lines followed by an example. Next concept, angle between vectors. Angle between vectors. Suppose we have two vectors a bar and b bar. Assume that theta represents an angle between these two vectors. Theta represents an angle between these two vectors. Then this theta can be measured in two different ways. One is by using trigonometric cosine function, another is by using sine function. Let us see how to get this using cosine function. Cos theta equal to a bar dot b bar divided by norm a bar times norm b bar. So this is the way we measure angle between two vectors using cosine function. Now this is a dot product and this is normal multiplication because the length gives some normal value, normal scalar expression. This is normal scalar expression. Multiply them. So this is a normal product. So here cos theta is given by a bar dot b bar divided by norm a bar times norm b bar. So using this you can easily measure the angle between two vectors a bar and b bar. Suppose if dot product is replaced by cross product, then cos theta will be replaced by sin theta. So in that case, this must be replaced by cross product. A bar cross b bar divided by norm a bar times norm b bar. But in the right side, something is missing. Can you guess? This is a vector. Cross product of two vectors is a vector. This is a scalar. So when a vector is divided with a scalar, the result is a vector. This is sin theta is some constant. How is constant is equal to vector? So therefore this must be length. So therefore when dot product is replaced by cross product, then cos theta is replaced by sin theta. So you will get the result like this. So when you want to find angle between two vectors, always prefer this. Even if you follow this, you get the result, but it involves cross product. It takes some time. Finding dot product is much simpler when compared to finding cross product. Okay, but both will give same result for theta. Let us see an example. Suppose I have a bar equal to, for example, I bar minus 2j bar plus 3k bar. Suppose b bar equal to, for example, minus 2 I bar plus j bar like this. So I don't have k bar component. Now let us multiply these two. So when you apply this, the result is a bar dot b bar equal to, I am applying at first dot product. So 1 into minus 2, and this one is minus 2 into minus 1. So in order to get value symbol, I will do one thing. So I can take here also minus. Then I will get value easily. Even if you take plus, you will get the value. But here it is very simple for me. So minus 2a bar minus 2j bar. 1 into minus 2, minus 2. Minus 2 into minus 1 plus 2. So 3 into 0 divided by length a bar. So I am not finding because numerator is anyhow 0. So therefore this is the angle directly. I wrote directly angle. So here cos theta equal to, numerator is 0. So theta equal to pi by 2. So the angle between these two vectors is 90 degrees. Okay. So write the definition at first. Let theta be an angle between the vectors a bar and b bar. Let theta be an angle between the vectors a bar and b bar. Then write these two formulae followed by this example. Next definition, orthogonal vectors. Suppose we have two vectors A bar and B bar. We say that these are orthogonal vectors if the angle between them is 90 degrees. So two vectors are said to be orthogonal if the angle between them is pi by 2 or 90 degrees. The example is previous. Now, when you apply formula number 1 to measure the angle between these two, so we have cos theta equal to A bar dot B bar divided by norm A bar times norm B bar. Here I am saying that if the angle between two vectors is pi by 2, then they will be called as orthogonal vectors. That means theta is 90 degrees. So when theta is 90 degrees, then my expression becomes cos pi by 2 equal to A bar dot B bar divided by norm A bar times norm B bar. Now this is 0. Therefore I can write it as A bar dot B bar divided by norm A bar times norm B bar equal to 0. Now this is a ratio. When ratio becomes 0, only if numerator is 0. This implies A bar dot B bar equal to 0. Therefore, if you want to say that two vectors are orthogonal, just prove that dot product of two vectors is null. So if the dot product of two vectors is 0, then those vectors are called as orthogonal vectors. So the result is A bar comma B bar are orthogonal if and only if theta equal to 90 degrees, where theta is angle between these two. So do you know the meaning of this? This is nothing but if and only if. Or sometimes they use this notation IFF. So it means that if the vectors are orthogonal, implies the angle between them is 90 degrees. If the angle between them is 90 degrees, they are called as orthogonal. In both the ways, the statement is true. That is the meaning of if and only if. So write the definition first. Two vectors A bar and B bar. Two vectors A bar and B bar are said to be orthogonal. Two vectors A bar and B bar are said to be orthogonal if the angle between them is 90 degrees. If the angle between them is 90 degrees. So work out this. After this, write this note.